Hi, this is Alex from devstories.eu. NVIDIA NeMo Guardrails, episode 10 of 10. Building safety rules directly inside a Python script is great for testing, but terrible for scaling across a polyglot enterprise. If your front end uses Node.js and your back end is a mix of Python and Go, you cannot duplicate your safety logic in every language. The solution is using the 3 enterprise integration patterns for NeMo Guardrails. Take a standard migration scenario. You built a customer service bot prototype using LangChain. You added guardrails to stop it from talking about competitors. It works perfectly on your laptop. Now you need to migrate this prototype into a scalable production microservice architecture where multiple applications will query it. You have 3 primary ways to integrate the guardrails to make this happen. The first method is the native Python SDK, specifically an object called Rails. This is the core engine. If you are building a custom Python backend from scratch without relying on orchestration frameworks, you use this. You instantiate Rails, point it to your configuration directory containing your Golang and YAML files, and use it to process inputs. You pass in a list of message dictionaries representing the conversation history, and it returns the evaluated response. It is direct and gives you raw access to the underlying guardrails mechanics. Since you already have a LangChain prototype, rewriting everything to use the raw SDK is wasted effort. This is where the second method applies, which is the LangChain integration using runnable Rails. NeMo Guardrails integrates natively into the LangChain expression language. You create a runnable Rails instance loaded with your configuration and attach it directly to your existing chain. If your chain takes a prompt, retrieves documents, and calls a language model, you wrap that entire flow with a guardrails runnable. The guardrail intercepts the input before it hits your chain and evaluates the output after your chain generates a response. Your core application code barely changes, but your LangChain logic is now protected. This is the part that matters at scale. Consider the broader enterprise. Another team wants to use your exact same safety policies, but they are building a web gateway in Node.js or a high-performance router in Go. They cannot import a Python LangChain object. For this, you use the third method, the standalone API server. NeMo Guardrails includes a built-in server you can run via the command line or deploy as a container. You start the server and point it at your configuration folder. It immediately exposes REST endpoints that mimic the standard OpenAI API. To your Go or Node.js applications, the Guardrails server looks exactly like a standard language model. They send standard JSON requests to the chat completions endpoint. The server handles the input guardrails, communicates with the actual underlying model, processes the output guardrails, and returns the clean text. Decoupling your rules from your application logic using a standalone server is the only reliable way to enforce consistent safety policies across an entire organization. Check out the official documentation to try these integration patterns hands-on, or visit devstories.eu to suggest topics for future series. Thanks for spending a few minutes with me. Until next time, take it easy.